So, again, we are on the tab that is labeled rectangles. Okay, what we write on this slide as well as the next slide, there's two more pictures you have to draw after this slide. All needs to be copied on the left side of your rectangle flap, so the part down low, okay? Then we'll have another slide you write on the right side of the flap, and then we'll have one more where you have to write on the top part, okay? So make sure you plan accordingly. All right, so first we've got our properties of a rectangle. First, it has all 5 properties that our parallelograms have. So, still, opposite sides have to be congruent. Opposite sides have to be parallel. Opposite angles are supposed to be congruent. Consecutive angles have to be supplementary, and diagonals still bisect each other. So, all the 5 properties of a parallelogram still going to hold true. Okay, rectangles also have a couple of their own. Okay, so you can draw this figure over here beside it to show all those 5 properties. So if you see here, they marked top and bottom are congruent, ends are congruent. They marked ends are parallel, top and bottom are parallel. And then they marked that the diagonals are bisected. Okay. All right, our second property, which is something you guys already knew, is that rectangles have 4 right angles. So of course, their opposite angles are going to be congruent because they should both be 90 degrees, right? And of course, that means that consecutive angles are supplementary because 90 plus 90 is 180. All right. So this is what that would look like in our figure. We've got right angles in each corner. All right. And we are going to know that those diagonals are congruent, which we already marked up there. Now we already kind of talked about this, but I think you guys had an example on, I think it was 7.1 day 2, where you proved where the midpoint was for the diagonals. Okay, we could also still use distance formula to prove that this diagonal and this diagonal should be the same size. Right? Okay, does everybody have those? Oh, yes, and this is what that would look like, which you guys already did draw up there. So, just that our diagonals are bisected here, but now we also know diagonals are the exact same length, which was not necessarily true in our parallelograms, right? They just bisect each other in parallelograms. Here, we know that they're congruent. Okay? So this is going to form 2 isosceles triangles with the base angles. All right? So remember, isosceles triangle has 2 congruent legs and therefore 2 congruent base angles. Right? So there those are, top and bottom. So the legs formed by the diagonals, since diagonals are congruent, will actually be the triangle at the top half and the triangle at the bottom half. And there's 1 and 2, the 2 congruent base angles. And it'll be the same in the bottom. Okay, and then we should also have 2 more isosceles triangles on our edges, right? So those would be on the 2 ends. So this could be helpful whenever you're doing your proofs. If you're needing to prove something is congruent, you're automatically going to know I've got 2 isosceles triangles here and 2 on the ends as well. And there are your congruent base angles highlighted in yellow. All right. Everybody have all that? Okay. So a couple more pictures. We're still on that left-hand side there. Okay. So you don't have to draw it near as big as they did. But they ask, why are the diagonals of a rectangle congruent? So what do you guys think? Why do we think that the diagonals are congruent here when they weren't necessarily congruent in a parallelogram? Okay. Awesome. What else? What else do we think? Anybody have any other ideas? Okay. So if we were to look for AC, the length of AC, what would we do? Okay, right. If they gave us lengths, we could use Pythagorean theorem, and it should be the hypotenuse. Very good. If it was on a coordinate plane, and they gave you the points of A and C, then you could use distance formula. They should be, right? Or 45, 90 if we're in a square, right? So it just depends. Also, you know, same thing, this direction. If we wanted to find BD, like Katie said, we could use Pythagorean theorem. Or if it's on a coordinate plane, we could use distance formula. And doesn't really matter which we are using. Whenever I do Pythagorean theorem or whenever I do distance formula, we should end up getting that those are the same length either direction, right? All right, so this is going to go on the other half of your page. So just kind of like when we did parallelograms, first we wrote our properties, now we're writing our theorems, or the ways that we can prove. Okay. So number 1 says if the diagonals are congruent, then it's a rectangle. Okay, so if you can prove your diagonals are congruent, which, like we said, Katie told us that if we do Pythagorean theorem, then we can prove that they are congruent in length. Or if it's on a coordinate grid, you might be given the coordinate points for those corners, and then you could use distance formula to prove if those lines are the same length. Okay? And then we have a rectangle corollary. Corollary, again, kind of like a postulate or a theorem. It's just basically a little rule that we tag on. It says that a quadrilateral is a rectangle if and only if it has 4 right angles, which we already kind of knew, right? I think there's only one more slide that you have to fit on the left side of your page after this one, so you don't have to fit quite as much information on this one. Okay, everybody have that? So again, this corollary just says it's a quadrilateral is a rectangle if and only if it has those 4 right angles. Okay. All right. So this, oh, okay, there's only the one slide. So this part you're going to copy up on the top portion of your rectangle flap, so the part that's folded up. Okay. It says that they want you to find all of the angles in rectangle MNOP. Okay. No, you can just copy these up at the top of your page. And then it wants you to also find GE and KH over here in rectangle GHJK. And KE is 2x plus 3, GJ 6x minus 14. Okay, so over here in our rectangle MNOP, okay, they told us that this angle POM is 26 degrees. Okay? So what could I maybe do to find angle NOM, this other piece? Exactly, right? Because it should be a right angle. Yes. That's fine, whichever, as long as you can fit it up on that top part, whatever you prefer to do. No, it doesn't matter, as long as you've got it copied on that top part. Okay? If we were trying to find angle NMO, so this portion right here, what should it be? Why? Alternate interior angles, very good. And then this one should match what we got here, right? Okay. So you guys told me first we knew it would be a 90-degree angle, so we could find the other half here. And then, because these are all congruent, we know which ones should match, right? Okay, then in the center here, they said to find this angle. Well, once we know this is 26 and 26, we said we had this isosceles triangle, right? Well, if 26 and 26 are already taken up, we would just subtract from 180 to see what's left for this angle. And if this angle is 128, what should that one be? Right. Okay. And then I could either add the 64s together, subtract from 180 to find what these angles should be, or we could say this is a straight line, these two and these two should be a linear pair, right? Which would leave us with these two here. All right. Okay. So go ahead and make sure you have your rectangle over here labeled not only with the letters they gave you, but also go ahead and write your 2x plus 3 where that would go, and your 6x minus 14 where that would go on your figure. So KE is this portion, right? And GJ is this entire diagonal. Okay? So what do I know about half of this diagonal and an entire line here? What should be the relationship?
Half of the line is half of the entire.
Right, so if I wanted to set them equal to each other, what would I have to do to KE? Very good. So that piece is the 2x plus 3. Here's our 6x minus 14. And like you guys said, if we wanted to set something up to solve, we'd need to double KE in order for it to be equal to GJ. So we'd set something up like this. All right. So 2 KEs equals 1 GJ. So 2 times 2x plus 3 would be equal to 6x minus 14. If I was going to solve this, what would I need to do first? Right, we distribute that 2. And we have 4x plus 6, right? And then we start moving our variables and constants to the same side. So once we move our stuff from side to side, what are we going to end up getting for x? Nice. Okay, and then if they wanted to actually know the lengths of those segments, we would just do what was that 10. Plug it back in. Very good. All right. Okay. Everybody have that? Oh, sorry. There's the part where they go set it back in. Okay. All right, so now we're going to talk about a rhombus. So go to your tab for rhombi. This one doesn't have as many slides. I think it maybe has 3 slides total. Maybe just 2, I don't know. All right. Okay, so copy this on the left side of your rhombus flap. So the first thing we're going to list out is all the properties of a rhombus. Again, a rhombus has those 5 properties that a parallelogram has. Okay? So it's got the opposite congruent sides, opposite parallel sides, opposite congruent angles, supplementary consecutive angles, and bisecting diagonals. Okay, so they have that marked here on this figure. Okay, the second property is that a rhombus has 4 equal sides. So not only should top and bottom and the sides be congruent, all 4 sides should be the same size. So if they give you a rhombus and they tell you this side over here is 3, you automatically know all the rest are 3 as well. Okay? Here, not only are you going to know that your diagonals bisect each other, the other property of a rhombus is that the diagonals are perpendicular. And what does that mean? Forms 90-degree angles. Very good. Okay, so that would mean if I am now going to have 4 triangles with a 90-degree angle here, we now have 4 right triangles. Okay? So if I ever have a missing side, I might could use Pythagorean theorem to find the missing piece. Okay? So there's our figure where it's going to create 4 right triangles. Diagonals will bisect the angles. So it's referring to the angles here in the corners. Okay? It's saying it's going to bisect those, which means what? Very good. So, if they told you that this angle is 20, you're automatically going to know the other is 20. Right? Same with the other corners as well. Now, this does not necessarily mean that this angle and this angle are congruent to those two. Right? It just means that these two are split in half and they're measured to be congruent, and same for the other. But okay, so what conjecture can we make about each red and blue angle pair? So basically, what do you take away from that? Anybody have any ideas? Yes, we do. We have alternate interior here and here. Yes, very good. Because we do know that our sides are parallel. Nice. What we should also take away is that these are going to be complementary, right? Because we said that every single one of these has a 90-degree angle here, right? So within the top half here, I have a right triangle. Well, if 90 degrees of the triangle is already taken up, how much should be left? 90. For them to split between these two angles. Not necessarily evenly, right? But whatever this one is, let's say this one is 50, then this one would have to be 40, right? Something along those lines. So, whatever these two angles are, here and here, in blue and red, are going to have to be complementary, which means adds up to 90. All right. Oh, did everybody have that? Sorry, I didn't ask before I changed it. Okay. All right, copy this on the right side. So these are your theorems, or your ways to prove that you have a rhombus. So first we've got our corollary. It says a quadrilateral is a rhombus if and only if it has 4 congruent sides. So one way we could prove it is if all of the sides can be proven to be the same length. Okay, our second is if the diagonals are perpendicular. So if all of your diagonals cross and are forming 90-degree angles all the way around, then that's enough proof to say that you do have a rhombus. Our third is that a parallelogram is a rhombus if and only if each diagonal bisects a pair of opposite angles. So remember we said that it would bisect the angles in the corners. I don't remember if this has pictures. No, it doesn't on that side. So again, this is for the top flap to copy down a couple of examples. So draw this picture, and they want us to find all of the angles in the figure. Okay, well if this angle is 36, okay, first of all, what am I going to know if this is a rhombus about all of the angles around here? They're all 90 degrees, right? So then if this is 90, then this one's 90, then this one's 90, then this one's 90. Okay, we said that also that these diagonals bisect this angle. So if this side is 36, what should the side right beside it be? 36 as well, right? And then that translates down here to this corner too, right? So then I have some triangle up here with a 90, a 36. How could I find that missing angle there? Subtract, very good. And then that would leave us with a number here that would automatically tell us these angles as well. So we know it's a rhombus because it has all those 90-degree angles like you guys said. If that angle is 36, the one beside it must be 36, as well as the angles across from it. Like you guys said, we would subtract in our triangle to figure out one of the missing angles, and then that's what all the others should be as well. Okay, over here, copy this parallelogram down. It says to find the perimeter of parallelogram ABCD if AC is 24. So AC would be this diagonal, and DB, this diagonal, is 10. Okay? Well, we know that our diagonals still bisect each other, right? So if this whole line is 24, what would this piece be? Okay? And if this whole line is 10, what would this piece be? And we know this is a 90-degree angle, so what could I maybe do to find this side here? We don't know for sure because we don't know if these were split evenly. That's not one of our properties of a rhombus. Very good. So once I know what this side is, what's our rule about a rhombus? All sides are the same. So whatever this side is, add them all up. Okay? So like you guys just told me, we know because it has that 90, we went ahead and label our pieces like they gave us the information for. We used Pythagorean theorem to find the missing side. So one side must be 13, and if one side is 13, like you guys said, they all are. So perimeter, we add them all up. I'm going to go ahead and bring these around to you guys while you're finishing copying this, but we do still have a couple more slides to copy down, so don't put up your flipbook just yet. We still got a few more minutes. Okay, everybody have those? Okay, now we are going to copy down a couple things for our squares. So flip to your squares tab. Okay, first for properties of a square, we're going to put this on, I think there's only 2 slides for here, so you could copy this anywhere on the main flap. Again, it's going to have all the properties of our parallelograms. So opposite sides are parallel. It's also going to have all the properties of a rectangle. So the diagonals are going to be congruent, and it's got all 90-degree angles. It also has all the properties of a rhombus, which means all the sides are congruent and the diagonals should form right angles or be perpendicular. So these are all going to be 45, 45, 90 triangles. So remember, if we know one of the side lengths is 11, then we know that the hypotenuse is 11 square root of 2. 11, 11, 11 square root of 2, or whatever our sides are. 7, 7 square root of 2. 3, 3, 3 square root of 2. So you can use any variable. N, X is what we used on our notes a lot. Okay? And a parallelogram can only be a square if it contains at least one property specific to a rectangle and one property specific to a rhombus. Give me a second to copy all that down. Yeah. And you don't have to copy everything word for word. Basically, what we should be taking away here is it's got the properties of all previous figures we talked about. And in order for it to be a square, it's got to have at least one property that was specific to our rectangles and one that was specific to the rhombus. Okay. All right, everybody have this slide? Okay. All right. So it says a square park has a diagonal walkway measuring 58 feet. Find the perimeter. Well, if this is 58, then I should be able to find these sides as well, right? Because this would be a 45, 45, 90. So 58 should be set equal to what? Very good. That was the theorem, basically, that it has to have the property of a rectangle and a property of a rhombus. So, like you guys just said, we know which sides are our x's, and we are setting x squared to 2 equal to 58. We solve and get our x. So it's going to give you some square root answer, which they went ahead and typed in the calculator, which is approximately going to be 41. All right. If we want to find the perimeter, all you have to do is multiply that number by 4. Area, length times width, so square that number. Oops, sorry. Okay. So when you guys come back from spring break, we will review these 3 figures, and then we will have a quiz come up pretty quick after that. All right? So have a good spring break.
You too.